Chemistry 3.2a. Hopefully the little delay with lessons means everyone's caught up. Probably not. Alright, so 3.2a, now we're getting into the nitty gritty of chemistry. Ions and ionic bonds. Okay, so as per usual, you're gonna put your titles in your notes, ions and ionic bonds, and write out the bullet points. Okay, so here we go. All right, so we have helium, and when we look on the periodic table, we see that it has two numbers, a 4 and a 2. It doesn't matter whether these are on top or on bottom. The smallest number is the proton number. The biggest number is the nucleon number, also known as everything in the nucleus. Okay, so let's look at this in terms of charges, meaning pluses and minuses. All right, so our helium has two pluses, bang, bang, because it has two protons, right? And it has two minuses, bang, oh, come on, bang, bang, which means overall its charge is equal to 0. Make sense? The plus and the minus cancel each other out. The plus and the minus cancel each other out. So the rule that you need to know is, I don't know where I left off. I hope that worked. I think I mistakenly didn't press the button or something. And what I said was, okay, atoms have no charge. But what if I took my helium atom, which has two protons and two electrons, and I stole one of the electrons? Now you would notice that it has two pluses and one minus. These two cancel out, so now it has an overall charge of +1. The second my atom has a charge, it is no longer an atom, it is an ion. And ions are atoms with a charge. They have, it's weird, I think of them like ghosts. So let's say, for example, I had my helium or my gold atom. Let's say I had gold. I hope gold is AU. I feel like it's not. I'll change it to iron. I don't care. So let's say we had an iron atom. Okay? And an iron atom, is silver. Not silver, it's shiny. It's hard. It's metallic. And it, hold on. It is attracted to magnets. If I gave this atom a charge, so if I turn it into Fe2 plus, so that is an ion, it doesn't necessarily have those characteristics anymore. But I can turn it back into an atom. This is kind of going too far, but you need to recognize that ions can turn back into atoms, and atoms can turn back into ions. But they don't always have the same physical characteristics. But the gist of what I'm trying to say right now is ions are atoms with a charge. Okay? Charges are plus and or minus, and they can have as many charges as they want or that they can carry. +2, +10, +50, whatever. Now, the way that we give an atom a charge, so let's stick with helium again, 2 p's, 2 n's, 2 electrons. There's two ways to give this a charge. I can either increase the pluses or decrease the pluses, or I can increase or decrease the minuses. You actually can't increase the pluses, because if I gave this one more positive charge, it would turn from helium into lithium, because lithium has a proton number of 3. So messing with the pluses isn't going to work for giving our atom a charge. The only way to give your atom a charge is to increase or decrease the negatives. Oh, that was brilliant. And the negatives are your electrons. So ions are made by changing the number of electrons. How do I make something more positive? Oh, I like this part. If you want to make something more positive, so if I was a very sad person, how do I become more positive? So let's say this is me, and I'm having a bad day. Okay, no, that means you're dead. How do you get happy? Basically, you find somebody smaller than you, and you shout at them. You get rid of all your negativity. Once you've gotten rid of all your negativity, you're happy again. So if you want to become more positive, you get rid of the negative. A little trick in chemistry, don't memorize both sides of the coin, just memorize one. How do you get more positive? Get rid of the negative. Vis-a-vis, how do you get more negative? You have to take on the negative. If I want to become more negative, I just add more negativity. But you understand what I mean by just memorize one side. So, let's make a note. To become more positive, you get rid of electrons. To become more negative, you add electrons. That's it. So in the syllabus, they gave you scientific words. I think they say, describe the formation of ions by electron loss or gain. There you go. How do you make an ion? Gain or lose an electron from an atom. Boom! Now, the only groups of atoms that will make ionic bonds, and it makes life a lot easier when trying to figure out ionic bonding. Ionic bonding happens between metallic and non-metallic. I get my kids in S1 to memorize metal plus non-metal. So ionic bonding is metal plus non-metal. You can kind of see the word ion in there. Hey nah, hey nah. So ionic bonding only happens between metallic metals and non-metals. Use your periodic table, figure out if something's a metal. If it's a metal plus a non-metal, it has to be ionic bonding. Period. Alright, so how does ionic bonding work? When a metal and a non-metal react, so let's take our metal as lithium and our non-metal as fluorine. So lithium plus fluorine, okay? Now when it comes to ionic bonding, nobody cares about the protons. You're not changing the proton number, so there's no need to write them in. What really does matter are your electrons and that they're written up properly. The most important part of the electrons is the outer shell, but because we're just starting, let's go with drawing the whole thing. So what would lithium look like just as electrons? It would have one shell with 2 electrons, and its second shell would have 1 electron. We know that because in the previous lesson you learned it's 2, 8, 8, blah 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 blah. And after you fill the first one, you know lithium has, you move on, after you fill the first shell, you move on to the next one. You know lithium has 3 electrons because it has 3 protons in its atom. So lithium is, why would I do it in red? What a numpty. Boom. Okay, so lithium has 2, 1 as its electron configuration. 2 in the first shell, 1. Oh, I did the red again. 2 in the first shell, 1 in the second shell. And fluorine has 2 in the first shell, 7 in the second shell. Okay, that shouldn't be rocket science at the moment. Now, all elements, everything in the universe, want to have a full outer shell. So we have 2 options. This guy can either add 7 to make that 8, or it can lose 1 to make that 0, and then his 2 would be full. That would technically be a full shell because this one, I'm pointing with my finger like you can see me, this one would no longer exist. And fluorine has 2 options. He can lose 7, or he can gain 1. And they tend to go with the easiest one along. So what ends up happening is, ooh, I wonder if this is going to work. Can I grab the E? Come on, let me grab the E. Why would I want to grab all the E's? Okay, I have an idea. Pause. There we go. So in order to make its outer shell full, it actually loses this electron, and that electron comes over to this family, and this shell disappears. So now, technically, lithium now has a full outer shell. It has 2 in its outer shell. And fluorine, when you look at it, it now technically has 8 in its outer shell. Good job, Neville. See? 1, 2, 3, 4, 5, 6, 7, 8. Full outer shell, happy. Full outer shell, happy. But there was a slight change. Because this lithium lost negativity, it became positive. If I'm less negative, I'm more positive. And because this guy gained some negativity, it is more negative. And the fact that they have a plus and a minus, opposites attract. I don't know if you can hear that. Opposites attract they are now attracted to each other. Boom. That is an ionic bond. Okay? So there's like 7 things to talk about all at the same time. Alright. If an ion has a positive charge, it is called a cation. And if an ion has a negative charge, it is called an anion. Now, to help you remember, you have 2 things. I remember that cats make me happy. Okay? Hold on, my phone's ringing. Okay, so cats make me happy. It's a silly joke I teach with the S2s and the S3s. Or you can remember this picture. The cat has big positives on its eyes. Another one to remember, the word cation actually has a plus in it. So, I don't know. Whichever one works for you. So, cation, cats make me happy. Cat ion with the T, whatever. So, what I was saying before about once you learn one, you don't have to learn the other. If you know that cations are positive, then the other word must be negative. Just learn one. Make your life a lot easier. What else was I gonna get at? Silly phone call. Quick point to note: metals will always be cations. I guess I should write that down for the groups of people that aren't actually writing. Metals are always cations. That's their jobs in everything. Okay? Metals are always cations, and you can also tell how many electrons are in the outer shell by its group number. So you'll notice on your periodic table, you'd have a bunch of elements set up, blah blah blah. Hold on. On your periodic table, no, I definitely copied it. What's the wrong button? There we go. Okay, so on your periodic table, you would notice that everything is set up, and I think we've spoken about this before. But you have these numbers up here that are called your group numbers. 1, 2, 3, 4, 5, 6, 7, 0. These numbers tell you, without you having to do anything else, electrons in the outer shell. Go ahead and check it for yourself. But lithium has 1 in its outer shell, sodium has 1, potassium has 1, and you don't need to know any higher than that. Beryllium has 2 in its outer shell, so does this one, so does this one. You would never have to figure out these groups at this level. Yes, there's a way to do it, but no need to know it. And the same. 3, 3, 4. Another little trick, if you read the syllabus through thoroughly, you only have to know up to element 20, which is whatever this is. I can't see underneath. So you only have to actually know everything inside and out about these elements. Okay? But yes, group 1 has 1 in its outer shell, group 2 has 2, so there's no need to actually draw. I'm going too far. Nice. There's no need to actually draw them out this big. You can just draw the outer shell. So instead of drawing lithium like so, hold on. So instead of drawing lithium with 1 shell, 2 shell, blah blah blah, you can just draw the other shell. Lithium has 1 in its outer shell. Fluorine has 7. Alright, and then you can show that lithium loses 1. Everybody knows what the under shell has in it. They can lose and gain more than 1. If lithium loses something lost 2 electrons, it becomes plus 2. If it lost 3 electrons, it becomes plus 3. Same. -1, -2, -3. Now, ionic compounds are very hard to melt. They're very hard, they're very strong. And the reason why is because they're set up like this. Because of the way their charges are set up, they can create this. Actually, I should probably draw a box first. They can create this 3D structure of positives and negatives. And if I can get this to work with the pen, I'm a genius. So what happens is they'll have a positive charge there, and then on the other side it'll be attracted to a negative over here. Oh, that's not right. It'll be attracted to a negative, and then that negative is also attracted to a positive down here, which is also attracted to a negative down there, And let's see if I'm smart enough to do this. Hey no. Hey no. Boom. So when you look at how these things are attracted, there's attraction all over the place. It's being pulled together there. It's being pulled together there. It's being pulled together there. The amount of energy it'll take to separate this handful of ions is ridiculous. They're not gonna budge. Okay? So ionic structures create what's called a lattice where they all are attracted to each other. And it keeps them nice and strong, and they can all just lie about in any way. Let's say this ion is like that ionic charge is like that. Right next to it, you could have another one laying sideways, but it's still a positive and a negative. And then you could have another one like this, and it's positive and a negative. So what that creates is something called a lattice. Lattice, A-L-T-T. So what you get is this ionic lattice, which is just all these forces being all these opposite charges being attracted to each other. And if I took another block with the same idea, that would be attracted to the same block. It's almost like Legos or Connects. They can all attach to each other. And if this block had charges like that, it'll rest next to that one, and that one will rest next. You just can't break these bad boys apart. So as a result, they have this really high boiling point. It takes a lot of energy to break down, to separate an ionic compound. You will see lots of ionic compounds between group 1 and group 7. Okay, a lot of lithium, sodium, potassium, and fluorine, chlorine, bromine. One ionic compound that you actually know about already is sodium and chlorine, so it's called sodium chloride, aka table salt. Alright, so let's look at our syllabus and see what's up. Describe the formation of ions by electron loss or gain. Done. Describe the formation of ionic bonds between groups from elements from groups 1 and group 7. Done. That was the lithium and the fluorine that I did. Describe the formation of ionic bonds between metallic and non-metallic elements. That's what it is. You are giving away, losing or gaining electrons from metals and non-metals. Describe the lattice structure of ionic compounds as regular arrangement of alternating positive and negative ions. Now, that long spiel that I gave was just the explanation. They've told you how to describe it. If it said, hey, describe the lattice structure of ionic compounds, you would say it is the regular arrangement of alternating positive and negative ions. That's how you would say it, but it pretty much just means this, not that, that drawing there. Alternating negative positive ions. Is that all for ions and ionic bonds? Yes, it is. Neville out.